right. After a slightly longer delay, I have returned. We were trying to put together a list result, I believe. So why am I not getting? Let me close this file and reopen this. Sometimes, yeah, I don't know. Oh, let's just keep going. I think I can do this. Query dot items is interesting. That returns an array of item attributes that match the query criteria. Each element in this array consists of an attribute name and the value for that attribute. If no value was sent for this field, default will be set. If you want to determine if no value was sent, use is none. Okay. Here's query output. That's what we're dealing with. We have count, scanned counts, last evaluated key, consumed capacity, and items. Oh, I see. Right. Okay, that makes sense. So we want to do something where I guess I could just do this. In fact, we could do let items equals. Let's call this query output. Sure. Query output dot items dot unwrapper default iter map. And that, and then items is just that. There we go. And that seems not unacceptable. So then, that was an accidental import. So then what is the purpose of indexes as a field here? Well, the idea here is that in our main and our handler, we're going to do some validation where related field needs to be in indexes, or we fail out before we bother trying to call our new method to do the query. Now Copilot works. Validate against table configuration. So if table config indexes dot contains, if it doesn't, then we give a bad request. And then we call get related, except is that what I called it? I called it query. Sure. There we go. Expected. Okay, so we just need to do conversion as str value. So those are the right arguments, right? Value. Not exactly. So there should be something like JSON ID. Okay, and then we do things based on the result, right? So if we get an okay, we return items. We'll return cursor, even though it's currently hard coded to be null in JSON terms. And if there's an error, we give 500. And expected reference, found reference. Okay. Mismatch types, expected opaque type, future something something, consider awaiting. Right. Dot await. Okay, and that's good too. And then I added the route already to here. So we should be able to just like build this and push this. And hey, I have a task for that. We can try, see if that works. Follow up on this lunch order. It's about that time. All right, and we are. Did the build work? Why do I feel like it didn't work? That was too fast. What is this? Resolve LStack CRUD API, no such file or directory. Let's try running the script from the terminal. So if I do infrastructure, deploy or push Lambda, please provide service argument CRUD API. And then we have to provide environment variables. I think those are all in tasks.json in here. Export this, export this region. US West 2. That is the region that I'm doing this project in. It's fairly nearby. Only a state away. Okay. So still didn't work. Why not? Well, I guess I'm gonna figure that out. I don't think we need to cd ... anymore. That was when the script lived inside of CRUD API and I was doing some stuff where I was looking at the directory. Hey, that looks right. All right. I was doing some stuff where I was looking at the directory of where the script was and I was cding up to make sure that things would work regardless of where I ran the script from. But since we're running this from inside of from tasks, where I can just tell it to the current working directory should be the workspace folder. Current working directory of the executed script program admitted. Current workspace root is used. Should be fine. Yeah. Yeah, so our final layer that actually has the binary is about 16 megabytes. So now, if I were to open the front end, this is still not going to do anything because we haven't told the front end how to use our new endpoint. I guess I could try doing it by hand, except our index doesn't exist because we need to go back and do the thing that we were trying to do before. CD infrastructure, Pulumi up. And this should work now because we removed the other index. is this going to wait for the index to actually be created before it says successful? Maybe. All right, let's close all of this stuff. Let's go back to our data provider. We're going to implement getManyReference. So we're going to start with getMany, and let's async. Fetch resource data. How are we generating the URL? Get resource URL. So this is going to be different. In fact, let me go back a couple of layers. There we go. So we will need to generate this URL. Resource related field ID. We can do this. We can expand on this. Related field name is a string or it's undefined, or really just say it's optional. Same thing. String or undefined. So if we have related field name, we'll add that to the path name. Yeah. This is going to be something where we do this. Yep. Why do I have tabs? What happens? What has happened to my project? Current files not supported or ignored by biome. What? Okay. This is probably a consequence of me doing a workspace, right? Oh, now it's fine? Okay, cool. All right, so I'm gonna do related field name. Yeah, we have a target. Okay. All right, how does this work? So we have a resource. So the resource in getManyReference is whatever we passed as the resource here, right? So video clips. Target is this, and then we have an ID. And so the ID is params.id, I think. And then we get items back. Are there other, page info? And we'll just say there are no extra pages. This is to do implement pagination, maybe. Okay, so did we finish deploying? Looks like yes, it took 286 seconds to add the global secondary index. And now if we go to the front end, are we making a request? 500. Excellent. It's a sign of success. Failed to query related records. So the request went to my API gateway endpoint, records, video clips, stream ID, ID. That seems right. So we're interested in the video clips table, which is like the metadata table. We're interested in the field stream ID. We're interested in this ID. So debugging time. So let's go over to Lambda. And we have our new CRUD Lambda. Why is it new? Well, there was something. Oh, right. So, if you've been paying attention, you might have noticed that sometime between the last coding stream and this one, I switched over to using a Docker image for pushing the code up for this Lambda, rather than what was effectively a zip file that was getting pushed via Pulumi. Not only does that mean I can just what does that mean? It basically means I can use Docker build, I can build an image, and then I can push it up, and I can tell the Lambda to update. And I guess I could do that without Pulumi anyway, right? But just like building the zip file and then pushing it to through the command line, like I'm doing. But downside, of course, is that it's not really a downside in this case because we are pushing a binary image, the compiled Rust code. So we wouldn't, even if this was still a zip file, what would we do? Look at the binary. A downside if this was like JavaScript or Python or TypeScript or something like that is that you could actually look at the contents if you were doing a zip-based deploy. Now, I've been told, I've heard that it is more efficient to do this kind of image-based Lambda versus like a zip file. Although I suspect for Rust, it's probably not a huge difference. But anyway, so we were gonna figure out what's going on here. So we're gonna go to CloudWatch logs. I mean, if we look at the stats here, we should start to see not errors, because from the perspective of the Lambda, it returning a 500 to API gateway is not an error. It succeeded in what it's trying to do. We would have to look at stats in like API gateway to see like it as an error, like an HTTP error. But from here, we're not failing, we're succeeding. But if we look at the logs, look at the latest log stream, we can see we have a bunch of tracing, and we traced an error, failed to query related records, service error. Super. Maybe we can look at, so we received a request. So here's the request that came in. And you can see here's the trace where we say response failed, status code 500, latency 5 milliseconds. That's pretty good. Actually, what's the runtime? Well, we had some spikes here. I think this is when we updated the Lambda in the first hit. So that was a cold start. But otherwise, we're talking, 30 milliseconds response time. That's pretty good. All right, so some backend issues. Why? So yeah, here's the trace that we got. Failed to query related records. So something failed inside of here. Let's add. What did we do wrong? So index name of an index to query. This index can be any local secondary index or global secondary index on the table. Note if you use the index name parameter, you must also provide table name. Yes, which we did. That's that. expression attribute names. Adds a key value pair to expression attribute names. So we can see other examples of using this. So attribute names start with the exclamation point. Attribute values start with a colon. So that seems normal. Let's go back to where we were. Query. Key condition expression. The condition that specifies the key values for items to be retrieved retrieved by the query action. The condition must perform an equality test on a single partition key value. The condition can optionally perform one of several comparison tests on a single sort key value. This is how we can do some more like fancy querying in Dynamo by using sort keys, like this. Use the expression attribute values parameter to replace the tokens such as this or this with actual values. You can optionally use expression attribute names parameter to replace the names of the partition key and sort key with placeholder tokens. So here I'm just doing that because it's, whatever the client, so in multiple layers here, whatever is passed into this function, we don't specifically know. So we don't know if it's going to be safe or it's going to be a reserved word. So we're just aliasing it using expression attribute names. So this should be fine because in the context of this index, indexed field should be the partition key. Let's go look at the DynamoDB table and make sure that Pulumi set this up right, or that I used Pulumi to set it up right. However you want to think about it. Index. So we have a global secondary index. The partition key is stream ID. It is called stream ID-index, as anticipated. Let's do this. Let's split query up like this. We'll do query output. Query dot send dot await. So what's happening in the API call, right, is that send is being called and we're awaiting, and then this will look and it will see that we got the second half of this result, right, the error branch, and it will return that error back to our handler, and that will then in turn return the API gateway and then back to the front end. So can we inspect the contents of query in such a way as to see what it's going to do? Looks like it has a formatter, so we might be able to do like tracing info. Why does Copilot not want to suggest anything right now? That's interesting. Okay, so let's say query to run, and then actually making me have to remember how to do Rust. How dare it? Okay, So then let's try to deploy that. Interesting. So we're just kind of all over the place with this workspace stuff. Maybe while we're waiting for the deploy to happen, biome VS Code workspaces. Currently support for multi-root workspaces limited, making biome.js signed files placed in individual root folders sometimes invisible to the extension. Control F workspace. For now, you may need to set up an individual workspace for each folder that depends on biome. It's closed. September. Okay, so there's something about all right, deploy happens. Control Shift P, biome. Restart LSP server. Okay. Maybe that's the issue. Maybe that's it. Don't know. So if we go back to the front end and we see that the request happens again, then we can go to CloudWatch and maybe we'll have some more helpful logging. So query to run. Here we go. And so we just dump out our query builder, our query fluent builder, and maybe we'll make this bigger. So there's a lot in here. It's nice that it redacted the secret access key. Good on it.
Our struggle as artists isn't about appeasing the crowd. Rather, it's about tending to the broken parts inside of ourselves. We create things as a reflection of this struggle.
Maybe let's start from the bottom.
To study our perception of self.
Fancy data.
That wave isn't
Good. Secret access
necessarily
keys
a
also
thing
redacted here. Good job.
It is a state of mind which you constantly
Okay.
strive
Expression
for.
attribute values, (V).
This all comes from an
Here's our attribute value.
ideas aren't static.
String, and it's our UUID. £K
B,
is stream ID. Let's check something really quick. So when we are in here and we're preparing the expression attribute names, yeah, it's just hash map string to string, right? So it should be the right thing. That we're passing a string here. And then key condition expression. Oh, where? There we go. Sum £K equals :V. So that seems right. Filter expressions, exclusive start key, scan index forward, conditional operator, query filter, and then none. Presumably that just defaults to what it defaults to. Let's look at the Dynamo docs again. So here's an example of doing a query. And they have a key condition expression, the expression attribute values, a table name. How about an example where it's on an index? There's filtered expressions. We're not doing filtered expressions. Basically, think of this like doing a scan, except you do a query first to narrow. You take advantage of an index to narrow the set of results, and then you can do a filtered expression to exclude things, so you're not getting returned to you. Yeah. Yeah, that. Here we go, working with indexes, global secondary indexes. Excuse me. Describe table query global secondary index. So DynamoDB query, table name, index name, key condition expression. Presumably this is the partition key from the index. Probably see that if we see their example here. So they're adding global secondary index, index name, key schema. Hash and range are the kind of legacy names for the idea of partition and sort. So game title is the partition key provided within the index. Game title index. So game title. Expression attribute values. Be game. That. So this didn't really turn up much. Let's do this, and we're going to unpack this result. So if we get okay, bring output. That back. If there's an error, want to return the error. Like so. But we also want to do some tracing. Failed to query. Hopefully going to give us a little bit more info than we got from the other path. ERR. Something. Let's see if that's actually good advice. Flippy seems fine with it, so ship it. All right, how's my lunch doing? Is it here yet? Oh, apparently it is. Well, so many notifications on my phone. They are hard to notice because I have my phone on silent when I'm streaming. All right. So what we're gonna do, we're going to get this built and deployed. We're going to exercise it one more time. We're going to see what the result is. It's going to fail. We didn't change anything about how it works, right? So it's going to fail again. Hopefully we're going to see logging. We're going to speculate as to what the cause is. We're going to find someone's a raid. And that will be the stream for today, probably. So let's make that happen. So, hit refresh here. See, yeah, we got an error. Good. We go to CloudWatch. Go back to our log group. Refresh and see the latest stream, which is hard to believe it's that one. I guess it could be reusing the same stream. Or alternatively, I didn't wait long enough. Let's let it hit again. Then there we go. I think it's likely that when you deploy the Lambda or you update the code of the Lambda and it does another cold boot, a cold start, that it's going to end up having a new log stream rather, in the log group. So that's what I was looking for. Okay, so failed to query. There, we get some details. So you can see the other message that we were getting before. Failed to query related record service error. Because that's kind of the short of it. So one validation error detected, value pound stream ID index at index name failed to satisfy constraint. Must satisfy what? Oh. Yeah, I don't know how format works. It's just curly braces. Right? So, yeah. Okay, cool. That on the plus side, hey, look, we have better output when something goes wrong, which is good. But yeah, so I was just not using the right index name. So that explains that. I guess that means that's also wrong. I think I was looking at an example. Like, we have a bunch of examples where I was using formats. Somewhere. Okay, well, regardless. I guess maybe we can actually see this working. I thought maybe it was going to be a harder problem. I don't know why. Honestly, I think the simple, oh, there's a typo here, or no, you don't need this character here, or those sorts of things are super common. And especially inside is like things where things are stringly typed, right? So think about like you're writing an application and it's interacting with a database and you're writing SQL, or maybe it's a DynamoDB query like this, or whatever, where there's some syntactically meaningful thing that in your code it's just a string, right? You don't have syntax highlighting or anything in your development environment to tell you anything about what's supposed to be in the string. What's the structure of it? That's a likely place for errors, right? All right, so if we go back to the function, we should be able to see if I refresh its status. Yeah, see, it's updating. So we'll just wait until this says it's done. It should only be a few seconds. See, like that. And then we go over to the front end, and we still get a 500 error. Maybe it's a different error though. Okay, so we go to CloudWatch. Hopefully it's a different error. We want to make progress. We want to get to the next error, right? Failed to query. access denied. It's a different error. So this one's really straightforward. In my Pulumi code, p main.py, we have permission to interact with this table, right? So in our API class, we are passing in video metadata table, and we are giving the CRUD Lambda the permissions, all of these permissions, including query. Yeah, allow access to the hey. So Copilot's got hey, Copilot's back. Video metadata in table global serial. That very weird. I guess we'll do that. I don't really. It would probably be better to like spread, to like map over this to get the ARNs and then spread that into this list. Okay, well anyway, I'm not gonna invest too much. We're just gonna make this work. Plus side is that this, once this deploys, we don't need to like push table global secondary index object has no attribute ARN. It's a lie. It's a lie. Sequence table global secondary index. Doesn't have an ARN. Okay. So how do we do IAM policy? Okay. DynamoDB query GSI IAM role. This is probably something where we need to do like /star. Table, yeah, /index/star or something like that, right? So we can just do video metadata table ARN dot apply. Yeah, like that, right? So apply is a method on this ARN object. So the way Pulumi represents values that are determined at deploy time is that it's this output object, and it has an apply, so we can programmatically access the value at deploy time once we know what it is and manipulate it. And the result of apply is its own output. Okay, so we're basically going to say, hey, you can do all of these things also to all the indexes, which is fine. Really, the only thing that's going to make sense is query. If we wanted to be more like have our action verbs separate, like dedicated to the resource, we could have multiple statements, and we could have like a separate statement about queries, and we would give permissions for the indexes. But this is fine as long as we don't have a permission that's like do something to the index. I mean, I guess conceivably you could have a Lambda that manipulates its own, the indexes on the DynamoDB table it's interacting with in some way. You could do that. Okay, so give it another shot. We have a result, and the result has items, and it has data. It would be really cool if we could see it in the UI. Data map. So this should be an array of things. So that means our data provider is not doing something right. Result, items, map, clean record. That's weird. we doing in timeline? Oh, right. It doesn't have a title, so that's not going to work. We can display the key. There we go. So here are all the video files that correspond to the stream ID. Now, that's nice and all, but what we're really after is the silence detection stuff, right? So we could do something like span, oops, record key, and then typo, PRE, and then we'll do, oh, we don't need to do the whole record. Let's do the silence. Is that what it's called? Silence? Yeah. I was feeling concise. Wanted to be concise in my naming there. There's a bunch of errors, but it's probably fine. Probably old errors, yeah? If I refresh. Yeah, looks good. All right, so here's where we're essentially pulling the related video records for the videos for this stream and the silence detection segments that it found, which makes sense, although these are not in a particular order. But that's fine. We can sort when we want to. Are the times relative? I think I did make this. No. Okay, yeah. So these are, or rather, they are relative. They are relative to each individual video file. So what we would need to do is sort these, and then do we have duration information? Right, because we get the whole record coming back in here. So yeah, we do have start time. So what we should be able to do is take the start time of each video file and then add that to the start and ends of the silence segments. Span, it's called start time. Yeah, there we go. It's not pretty, but the whole point of this is that we already have a component from the Glowing Telegram project that puts all this together in a timeline that allows us to select sections and bulk create episodes. So the next step is to actually take this data, plug it into that component, get that component in this project, hook it all together, and show that here. But this is probably, I guess this was the hardest part. So at least I think it will be. But let's do this. Let's go find someone to go raid.